Okay, welcome to the Plasma Frontier. This is the, I don't know, quite a few different videos we've done so far. We're actually going to go through the car unit. This, Cleve has been doing a lot of work with the graphics and the blueprints done. And this is the car unit. It's based from the Peruvian car systems. It's basically two coils, one facing each other. Go ahead and tip the canister. This is what it would look like inside your car if you were to pop the hood and look on inside. Some of the things at the bottom and the top. What's missing on it is the demarcations on the outside of the canister. You want to actually make, let's see if I can draw this. I can draw on this. This is great. The top, the right color. You want to mark the top of your canister as the positive on the outside, so you remember which one it is, because these things look absolutely the same when they get constructed. The top and the bottom, they're mirror images of each other, and then the bottom, you mark on it a negative. Your connections are going to be fairly simple. We're going to run the positive lead off the top. Let me get in blue. And this one is going to the battery. And it's going to go to the positive terminal on the battery. And the reason for it is as you go to your battery, you have the alternator on one side and your battery is on the other. Your charges are coming from the alternator and charging your battery, but it's also going to your system. And so in this case, because the car is running, have an alternator on it, and it's pushing your basically plasma current towards the battery, it's going to go towards the positive end, or when we get inside, it'll be moving through the gravitational and magnetics. But anyway, this is the direction of flow through it. So keep that in mind. Clear everything. Okay, if you would remove the PVC, the outside of this is actually PVC pipe. We found here in America that 4-inch PVC pipe worked really well for holding everything. You notice that we're only, in this particular design, we're using just one coil at the top and one coil at the bottom, and we'll get into that in just a second. There we go. It's a interesting design, and the wire coming from the battery is going to come in attached so that the current flows anti-clockwise through the circuit. So it's coming from the battery on the positive, goes anti-clockwise into it. And on the whole thing, want to zoom in to the connection, please? In the center of the coil, we have basically solid wire. And in our case, we used iron wire, and we did anode it, we burnt it, and the copper wire wraps around it, but it really, the iron wire is not part of the circuit per se. In the jewel ringer circuits, it's known as part of the ferrite core, so the iron core. And it basically, the iron is excited by the electromagnetic field that is formed by the copper wire going around it, and gives up and accepts magnetic particles, electrons, easily, and it makes the system more energetic. Remove the copper wire, if you could please, Cleve. So we just have the ring of iron. Oops, you hit it wrong. So it's just basically, and zoom out just a bit. So that wire wraps around a couple of times and just tucked inside. It keeps your coil nice and round, which is nice. Go ahead and put the copper wire back on. So we're going anti-clockwise in, and it forms a spring, and we go down to the little cap. And what was really convenient with the spiraling of the copper wire going in, the balls that we used for containing gans, which is that white sphere below it, the soda pop bottle caps fit right over the top of it, and so they were easy to drill and easy to epoxy to place. And so that was a really nice find. And who knows, we might end up with a little trim off of that, according to Mr. Kesh, because of the type of plastics. It was kind of fun. We have the copper wire goes through that red plastic cap and down just into the sphere. And we're calling that pin going down there the Patrick pin. I thought I was the smart one and had figured that one out, and that would be a good way of energizing the gans on the inside. And it went, oh, no, you need to know about Patrick down in Australia. He's been doing that for 3-4 months now and has gotten super results. And I went, okay, that's the Patrick pin. So anyway, there it is. We've alluded to it. There's the Patrick pin. And it just allows the plasma to go into the stage 3 gans. And basically, rather than having to go 2 layers of plastic and it goes directly to the CH gans, and then you've got the thin plastic membrane at the bottom of the sphere that plasma zips through and continues down to the bottom. Let's pull back a little bit so people can see and tip down. So the pin just drops just in. Now the bottom, let's see, let's do the bottom coil. We've taken the similar idea and instead of iron wire on the inside, put in aluminum. And the simple reason is it's just the iron needs to be more in the line of steel in a good transmitter of signals. The aluminum seems to be one that's receptive. It's like a receiving antenna. The coil is actually wound the opposite direction because all I did was flip it over. And it spirals up what would have been clockwise, and this is now anti-clockwise also. It because everything will go the opposite direction when it comes around and back down at the bottom. So this is going to be the gravitational, which is clockwise. And the one at the top is your magnetical, which is anti-clockwise. And by definition, this one at the bottom, let me change my colors. This would be your negative wire coming off the bottom. This wire is then taken backwards to the back end of the transmission. And on my vehicle, when I installed that, I couldn't get bolt off. I was going to attach directly to the transmission. So I attached it to the splash guard on the bottom of my Chevy Blazer, which is a 4x4, and wrapped around the steel screw bolts in there and then tied it down really tight. And that gave a good solid connection to the frame underneath the transmission. So then from the negative, that goes to the back end of the transmission on the back of the car, and then the plasma energy works its way back through the whole engine back to the front. And I'm gonna clear that. Go ahead and tip it back down so we can see it and zoom out, please. Okay, remove the plastic ball, the big plastic ball. Take a minute to get and remove the plastic. There we go. Around there's another ball on the inside, and we'll get that in just a sec. But the gans that we put in basically allows this sphere that's on the inside, and all we did was find a ball that would fit down through the neck of the larger ball. And we up here in the United States, we happen to find plastic Christmas ornaments that fit perfectly. And it was really a wonderful find and very cheap and work. Anything that's kind of round in shape, end of a ball, you can get your little ball to a 2-part ball. Use what you can find. The gans that goes that surrounds this ball is the CH3 hemoglobin gans. And the reason for that is we're basically working at the first step of getting communications to our devices in what would be later on the Starship engine. And so this was a prototype moving towards Starship engine ideas. And so the CH3 with either the hemoglobin is formed with iron with your nanoplated copper and your zinc in the salt water with either a low charge or no charge going to it. The iron has a tendency to drip ever so slowly, little red-like droplets when it comes in contact with the material that floats on the surface, and all of a sudden I forgot what it's called, the amino acids at the top. Now, amino acids in your GANs box, without the presence of the iron, is a full sheet. But because of the iron, it forms spheres. It has a kind of a magnetic center to it that it forms in the amino acids are almost like your, you should have a gravitational center, and the outside becomes more of a magnetic sphere. It's like taking an egg yolk and putting the whites around the outside of it. It's rather interesting watching how it works, but it gives you that connection to the inside. In my case, I was playing with the wires and stuff on top of my CH3 hemoglobin generator bucket, and inadvertently myself rather badly, and I bled right down into the bucket and went, well, wasn't planning on doing that, but it's in there and that's what it's going to be. And so mine actually has some of my own hemoglobin in it, and as I said, we'll see how it goes. Let's remove the outside ball now and show the inside ball. The inside ball is fairly small, and as you notice that we've got more stuff on the inside. This particular one was a double half. It was sections, two hemispheres that came apart, and it had an access hole already pre-drilled in it. And so we took the little ball apart and we placed a piece of copper wire, and it was just a suggestion from Mike to do an infinity loop. And the rationale inside with this was, if it wasn't absolutely flat, had a little bit of a turn to it, a little twist, like it's 1 1/4 turns, something like that, that would sort of like a little propeller in there. And that piece of copper wire is nano. And it was just for guns and chuckles, go ahead and put it in like that and let it spin around on the inside in the gans in that ball. The gans that we used was gans of urea, and the reason is it was very caustic in the first place because of the way it's produced, and it gives you that human lymph portion of it to as your mental connection to it. If this bothers you, of course, in both cases with the gans of urine and the actual human hemoglobin in it, substituting things like gans of seawater or water for lymph is perfectly okay, and using just the CH3 on the outside is perfectly okay. And I'm going to go into a little bit more detail as we get into the specifics on the gans. But anyway, in addition, you see these two other spheres. The one on the left, darker one, is actually the smallest grain of caustic that you can find in your caustic. You need just a little bit, because when you get through with making the gans urine and rinsing it, once it's finally washed well, it doesn't have any odor to it. When you're making it, it has a kind of ammonia smell. After you get it all rinsed and nice, it's basically like gans of seawater. And by adding back a little bit of caustic, this will give a very alkali center. And we placed the little silver ball on the right-hand side. That's the tiniest piece of aluminum foil. It's that you use for, wrapping stuff to go in the refrigerator. Just a little piece of oil and wad up, and that goes inside. Then the ball was sealed up on the seam, and then the gans of urine was added with a syringe through the port that was already there pre-drilled in the ball. And then I used a 2-part epoxy to seal the ball shut, so that everything is contained inside the sphere. The CH3 gans, we can look at 2 different ways. One, you can say it's the internal sun. This is what's caused the energy. And the other part of it is when we look at the jewel ringer circuits, and you hear me talk about this time and time again, and I'm hoping everybody is looking into jewel ringer circuit. There is a ferrite core in all jewel ringer circuit. Well, ferrite, iron. CH3 is basically gans of iron, gans of steel, and we're using the heavy, the nano layer, and quite a bit of it inside this big sphere. If you can get it closer to almost a fixed form, the better off you're going to be. And the nice about the CH3 gans, the nano layer, the next portions of it, is that it's one of the few gans, it's the only one I found neodymium. The CH3 gans is one that if you wash it and you use the heavies of it, the heaviest gravitation of it, it is acidic and it is magnetic. You can actually drag a magnet for it and it'll follow a magnet. So it's one more bump on the ferrite core that we're using to set up the plasma fields. Okay, that's this to the outside. You got the back on. Go ahead and turn the thing down so we can see the bottom again. Remember, it's spinning the opposite direction. Spin out just a little bit in that orientation. And I'm going to introduce one more thought while we're looking at. Can you zoom out a little bit, please? A little further. There we go. Nope, too far. Out, out, out. I want to see both the pod. There we go, right at that level. When we're looking at this particular orientation, and can you spin at 90 degrees so they're side by side? It looks like we're looking down the axle. Turn the axle the other way. That's fine. If you take a look at Tesla's wireless circuitry, wireless transmitter and receiver, this is what you have. And it's beginnings of what is known as scalar technology. And this is really, really important. We are taking 2 plasma generators that are basically making a toroidal shape, one sending, one receiving, and there's basically a flow, and let's see if I can draw this right color. It's coming out and around and in, it's in and down, comes through as a vortice through the CH3. We start getting a plasma field, and we were doing that in pink, so it starts to form a bubble of a plasma field here. This is your primary plasma field, and from the lectures I've done previously, you also realize that there's secondary and tertiaries emanating out from it, and some are traveling in one direction and others are traveling in the other in there. So you can say that in this you've got some going this way and others going the other. Clear. Then I'm going to draw back in my first part. So we've got the plasma field starting at the top, funneling down into the inside because it's being transmitted through that coil, being picked up, and it's just like a plug plane now. Change color. This is your receiver antenna on the outside, going around and around, and then getting into it and setting up your spin. And so it really does set up a plasmatic force, possibly out the bottom. If this was a explosive or expansive system, it isn't. This is an implosive And so what happens is this leaving at the bottom is fairly diffuse and goes in many directions. This is basically your gravitational. Your top on the other end is your expansion. Change color. Out here it's forming this one. It's actually forming from what we are envisioning a vacuum at the top. And it's this vacuum that gives us this lift that makes the vehicle supposedly lighter. And that's the theory behind it. We're actually sucking the car up in the air a little bit. The things that we've noticed so far with most of the Peruvian style car units. Okay, we're back again. Sorry about the break. The discussion that we're having, and it's going to, as I say, the Flat Frontier Group is a research and development. And we're learning this as we're going along. And one of the points was brought up was that I was basically going to go into Schauberger's explanation of implosion technology. And basically, when we designed this, we used the implosion to look like this. And those of us that built the units and in a car were under the impression that we actually formed a negative pressure at the top and a higher pressure at the bottom. And the pause and the, like, wait a minute, you're quoting Schauberger words. And I went, well, it sets up the big hole in the top, which is the negative pressure, correct? No. And what happens is the negative pressure forms at the bottom. This is where the suck starts, and it forms this vortice in the middle, and the air is sucked into it. So one of the reasons that Cleve was trying to allude to and trying to get to say, is that we actually mount this unit upside down. And it may be the case. Currently, the way we have it oriented is with the positive side up, the negative side down. And what he's saying is that to actually get any kind of lift, you may have to reverse. You may have it absolutely upside down. The two units that are being tested right now as we're recording this, each of them is showing about a 20% increase in fuel efficiency, which is pretty cool for something that actually, by all definitions we know from mechanics and HOH gas and automotive, things that shouldn't do anything. This device should absolutely do nothing, but we're getting a 20% just right out of the box, mounted with the positive end up. Clear. This is where we have to do some experimenting. And the unit that Patrick is using, his older units, he was getting about a 60% increase in mileage. And as I said, 20%, if you didn't know any better, is a pretty dang good number for something that shouldn't do anything. But we were disappointed that it didn't do as well as it could have because of the experience we have with our team. And what Cleve is bringing up is we may end up having to reverse this. And for those that are looking at this one, you might give it a try. The other thing that we were looking at is actually in Patrick's unit, he has two of these units, and one is facing positive forward, and one of them is facing positive upwards. And those may have to also be reversed. And because he was, once again, on those units that he's testing, the new line that you see here, he's only getting 20%. And we're waiting for him to get back from holidays and be able to go over the data that he collected on his vehicle and compare and contrast it to mine. Mine, I've got the best highway mileage ever and went from 220 324 miles to the gallon to 242, and with same time. I mean, I didn't alter my driving for freeway at all. It was just standard, and then drove through saddle traffic and that kind of stuff. And so I was absolutely amazed at how much increase in mileage got just with that orientation. And what Cleve is talking about is we may need to actually flip these. So orientation may be a big thing in either the two directions. And the reason for that, if you get the negative pressure in the right orientation, so the negative is up, this might lighten the vehicles, be similar to what Ford Motor Company did with the Prius. They had the smallest engine that they could find that fit in it in the first place, and it wasn't cost effective to put a real expensive computer in it. They probably did later on, but they lightened the vehicle, and so the less weight made for better mileage. Boeing has an idea that if they put the plasma device in the nose of the airplane, which is basically a scalar technology, which is this unit here, that it actually either preheated the air in front of the plane, or it formed a vacuum or a negative pressure in front of the plane, and the plane was sucked forward in that direction. And so either this thing sucks you forward faster, or it sucks you up in the air. Either way, it should get you your mileage. And so this is the stuff that we're working on. We're trying to figure out why some of the Peruvian systems really, really well, and yet you throw them into another vehicle and they don't work very well. I'm pretty certain that if you mount this horizontal against the firewall, it's not going to work as well as if it was either pointing forward or pointing vertically. So these are some of the things of where you attach it may make a really big difference on what you get in your mileage. One of the other units that's going in, this will be on the east coast of the United States testing. It will be mounted behind the rear passengers and in the right orientation, but it's the only place that he had, so it's going to go in the back of the vehicle. Mr. Ash has talked many times that the unit itself should be mounted center of the vehicle, but between the, let's say, the driver in the front seat or between the front and back seat. So orientation and mounting is really important. Having it well secured is really important also. So you just don't want it flying around in the cabin with you. And that's not just because you think the thing will fly, it's because you don't want loose objects into an accident flying around. It's making that all your connections are. It took me an hour and a half just to mount this unit here in the engine compartment. I had to mount it right near the battery and the fan blades. And it's cool enough that I'm not having problems with the plastic melting, but it was the only place that was available in the car. The wires and stuff from the unit, we used fairly heavy strand wire in the two units that are being tested right now. I mean, not strand wire, really heavy solid wire, I should say. We're looking in the new Australian systems going in as a test is actually using nano-coated strand wire that's inside insulation and smaller gauge, meaning that we can get more wraps of wire around it so you have a better field started top and bottom. And then the stranding inside the wire is another multiplier. So you've got just lots and lots of surface area. I basically started with the catch teachings about a year ago in October, and I have worked my way both forwards and backwards through the teachings. And I was really into heavy wire because in America, a lot of wiring is 12 gauge, and I wanted to make sure that it was everything that was Magravs and stuff compliant with house code. So I was more heavier wire. What we're finding, much to my chagrin, is bigger is not better. Basically, we're looking at distance and surface area, so that the more surface area that you have, the better off you're going to be. So it's the surface area to volume ratios, both on the wires and the distances, makes a much bigger difference than just, you know, the herkiness of the wires. So you want enough that it's easy to handle in the line of it'll hold shape, but and not so thin that it's going to break or be brittle. The wires that go through the center, we've basically just eliminated a lot of the double doubles. We're going to be checking with Patrick and seeing if older units were actually similar to the stacker configuration, where you've got a magnetic, a gravitational leaning coil on the inside and a magnetical coil on the outside leaning coil. So it's a different way of looking at it, but in the Peruvian systems, from what I can see, the inside wire that's inside those is not connected per se to the circuitry. It's just strictly the outside wire. The inside wires, the inside rings and stuff, are basically idlers. Cost to build US, buying all new materials, less than $20. Time to pull your gans and stuff together, because you're using a tremendous amount of CH3, you may be looking at 2-3 weeks, you know, in production getting your gans. So it's going to take a little bit of time to get it, but the materials are not expensive. Okay, I want to bring you back, and any comments or thoughts on this?
Oh no, I think you've touched that. The thing about the direction, it's, as you say, it's all thoughts in progress, and you know, trial and error really, because there's always two ways of looking at all of this. I'd like to show people the coils that are multi-strand cable, and they're nano coating now. So I believe this is going to actually multiply it up many fold. And
right, and what we're finding that if we can go to smaller gauge wires, we can make the units smaller in size, which means they fit underneath the hood or the bonnet of the car easier. Mounting makes it easier because smaller. You might be able to use more of them if they're smaller. So these are all things to think about. And the one things that somebody like JCI Canada and some of the Peruvian teams have found is that these units actually talk to each other. That you not only do you have your vehicle and your car unit working on your car, that seems to work better if there's more of them in the neighborhood. So the more these vehicles running, the more interactions you have, the better it seems to be working. It's almost like a drifting phenomenon when you're drafting, I should say, and you find a big truck on the freeway in front of you and you hook in behind and it drags you along. It seems that when we have more of the units on the road together, the effect better. So this is some of the new things, and this is what all ourselves the plasma frontier, because boy, everything is really new out here. There's nothing known. So experiment, see what you come up with, see if you can improve on our design. We have to go back to the drawing board and see why our new models, which basically what you're looking at, where did we mess up? Is it in orientation? Is it some of the integral parts on the inside? This was our best stab at the time, at the moment, and as soon as we find out more, we'll give you another video to look at and do the improvement. Okay, we got a little further. So thank you for watching, and do you have any other questions there, Cleve?
Just one thing I'd like to say, in the last video that we did, I advised people to look into implosion technology, and I did a Google search. It's been a few years as I really looked at it. And then I recalled and found that if you look into implosion, Google it, they talk about vacuums and like hot drums and sealing them off and cooling them quickly and that sort of implosion. So refine your search with Schauberger or free energy. Otherwise, you're just not going to get any information on implosion at all. Not the stuff that we're talking about.
Very good.
Okay. Thanks to everybody. Thanks, Fraz.
Yeah, thanks for you guys' support. We appreciate those donations that have come in to the account listed below, and we'll just keep plugging at this to see what we come up with. That's our report. Success, yes. Was it as good as it was that we wanted? No. We'll make it better. So we're here.
Thanks, buddy.